I am Tracy Ostrom. I actually am at UC Berkeley out here in California, and I am a Globe partner. And also we started an Earth System Science Collaborative with some other Globe partners here in California. One of them is Peter Falcon. He's at NASA JPL, and they're one of the consortium of partners that are in this Earth System Science team. But I'm super excited to hear what you have to say about data puzzles, because that's also a big push for me in our program is data literacy and any resources I'm super excited to get and learn about. So thank you.
Great, thank you, Tracy. And Mike, you're next.
I'm Mike Chabot. I'm from the State University of New York at Fredonia, so about an hour south of Buffalo. We also have an ESS collaborative. We're kind of taking a very focused look at how we might be able to partner career and technical ed with the GLOBE program and with our state Department of Environmental Conservation. I've had fits and starts with data puzzles. John gave us a water cooler. John Griffin gave us a water cooler. I was going to be part of the pilot that happened the same week as the GLOBE annual meeting. So we decided not to do that. And I think John and I are going to try to do some work in the fall. But like Tracy, we have a big interest in data literacy and data puzzles are awesome. Can't wait to hear what you have to share.
Thank you, Mike. And I see we have two new people that joined since we began. Beck Batchelor. We're just doing introductions right now, so we're just going around and introducing ourselves. And Angela Rizzi also just joined. So welcome to both of you. So Richard, why don't you go next?
Okay, I just muted and I'm unmuting. Well, this is, I guess, a little bit of a reunion because I'm not sure at my age whether I trust my memory all the time, but I kind of remember, Katya, that you were at our one of our summer institutes in Denver with Metro State, and I think John and Mike were there for that. I forget what that was, 3 years ago or so.
With Janelle Johnson?
What's that?
With Janelle Johnson?
Janelle.
Yeah. Good memory. Yeah.
I think I have not actually seen Janelle for a couple of weeks, so we're kind of on our separate paths, but I'm sure we'll get together and do some more things later. We had our fourth delayed summer institute it was at the Rocky Mountain Arsenal in Denver, and it was a very small group. I think we had about 12 or so, and I think we made a video of it that we can share with teachers, but I don't know where that is. So anyway, we've been working with John and Deanna since we started our local Colorado collaborative, that this larger collaborative is kind of following in our footsteps.
Thank you, Richard. Next, Beck Batchelor.
I think everybody here knows me. I work with Katya in Series Education Outreach and previously worked with John at UCA. But yeah, I do all sorts of REU, undergraduate research, and faculty development and support type work in this field.
Thank you, Beck. Beck's part of the Colorado collaborative that Richard was talking about, and Katya, I'll talk a little bit more about that in a minute. So let's go to Peter Falcon next.
Hello. Let's see if my camera, is my mic working properly? There we go. Okay. Sorry, I'm actually eating lunch on my screens. My name is Peter Falcon. I work at NASA's Jet Propulsion Laboratory in Pasadena, California, and I do earth science education and communication there. I'm also a GLOBE partner and formerly what was called a master trainer. In fact, my mentor, my master trainer is Deanna, so she trained me in GLOBE. And I'm also a part of the California Strong collaboration as well. And just do workshops with teachers, classroom visits to work with them as well, talk to them about the importance of having satellites in space, studying our planet, and of course, climate change as well.
Thank you, Peter. And Peter did one of these webinar water coolers a couple months ago on NASA education resources and Earth system related, and we recorded that one as well. So we're trying to keep these recordings available so that they can reach people that aren't able to attend these in person and live. So Katya, that's why I wanted to record. So thank you, Peter, and thank you for sharing. And let's go to Bella next.
Hi, my name is Bella. I'm the education coordinator at the San Francisco Bay National Estuarine Research Reserve. We do hands-on estuarine science programs for teachers and for students. Some of you might know Matt Ferner. He's the research coordinator at the reserve. And really excited to get to know about data puzzles. I'm familiar with data nuggets, but haven't heard of data puzzles before.
Thank you, Bella. And last but not least, Angela.
Hi, I'm Angie Rizzi. I'm at NASA Langley Research Center and I work on GLOBE and my NASA data. So I was interested in this because we have a plethora of data.
Great, thank you, Angie. And yes, you do. And any way we can have opportunities to use those data in meaningful ways with students is a good thing. So we're looking forward to hearing more about what you have to share, Katya. I guess I said last but not least, but Deanna should go next. And look, Gary's here. Thank you, Deanna, for pinging Gary. But Deanna, do you want to introduce yourself and maybe a little bit for Katya about this project, you know, where we have different Earth system science educators, and some of them are GLOBE partners, some of them are not, but we're coming together in different regions. So Deanna and I thought of this idea, and we've been wanting to get this group actually together physically, and then COVID hit, and you know, so we're doing this kind of thing in the meantime, but we would love to get together with everyone eventually. But Deanna, go ahead.
Hi, my name is Deanna Tabakhorst, and I live in Colorado, and as John and Richard, and that's all, right? There's none, right? So we've been working on this idea of developing a network because we all sort of knew each other informally, and then realized that there was a lot of common cross opportunities for us to share and support each other. So we started this ESS collaborative group. GLOBE's kind of a hub, but there's also several universities, UCAR, informal educators that aren't necessarily GLOBE partners, but doing a lot of Earth system science work. So we've done things like mutually manning or presenting at our state science conference and things like that. So, so that's our group. We really felt that it had strength and continuity after a couple of years. And so John wrote a proposal actually to NSF to make it a national effort to see if we could find groups from across the country that would also like to do this. So there are 6 teams, including ours in Colorado now. And I wish COVID hadn't happened in that way, because it's really held up the opportunity to bring collaborative strength to the group, except through Zoom, which is hard sometimes. So nice to see everybody, and thanks, John. You didn't go, John.
Yeah, Katya knows me already, but yes, Zoom for collaboratives. I'm not sure if that's as hard as trying to fly a kite on Zoom, which is what Mike was doing before he came online. Mike, if you can share pictures of that, I need to see how that looks. So last but not least, again,
Yeah,
Gary
that's awesome.
Gary Harris just joined. Gary, we're just doing some short introductions. Can you say a little bit about who you are?
Yeah, sure. Hi, Gary Harris, Managing Director, Center for Sustainable Communities. We have a ESS collaborative a group called Just Science, and we're having a ball. We really are. This summer, for instance, we had 6 Just Science interns and such, and they did a myriad of things around earth science topics, everything from doing offshore wind to developing online tools for communities, to downloading my NASA data and exploring the heat island effect and extreme heat, et cetera, et cetera. So, and our interns came from UNC Chapel Hill, I'm sorry, UNC Charlotte, Georgia Tech, and Liberty University. So again, then the intern part is just one of the facets of what we call Just Science. So having fun at it.
Thank you, Gary. And Katya, as you can hear, we have some cool names of our collaboratives. California Strong and Just Science are just 2 of them. And yeah, we're hoping with the project really to, as Deanna said, build based on the strengths that each partnership brings to the table, and just to learn from each other. And so these webinars are one piece of that puzzle. And so we're thrilled to have you. I'll do a quick introduction of you if that's okay, and then we'll get started. Yeah. So
sounds
first
great.
of all,
thanks everyone.
First of all, I'll say that CERES is a partnership. If you haven't heard of CERES, it's a partnership between NOAA and CU Boulder, where hundreds of environmental scientists work together to understand the Earth system, including people's relation to the planet. CERES Education and Outreach is a member of the Colorado Earth System Science Collaborative since the beginning, and they support teachers and educators by providing professional development, free teaching resources, and opportunities to get involved with programs and connect with educators or scientists. Katya is an Education Outreach Associate at CERES, and she's currently leading the Hazard, I love this acronym, Hazard Education Awareness and Resilience Task Force, called Heart Force project. That sounds great. I first met Katya when she managed the education outreach for a multidisciplinary research project on hydraulic fracturing, which was called Air, Water, and Gas Sustainability Research Network. And before joining CERES, Katya was a middle school earth science teacher in Gunnison Middle School. So please join me in welcoming Katya.
Awesome. Well, thank you so much, everybody. It's wonderful to be here today. Can you give me a thumbs up if you see my slides, just to make sure? Okay, cool. Well, yes, as John said, I met him several years back, and when I worked on air, water, gas, I also worked for the University CU Boulder Office for Outreach and Engagement, and I got to do a lot of this type of work of networking and building networks. So when Beck brought up this opportunity, I was really excited because I always love to connect with people and learn about what other folks are doing. So thanks so much for the opportunity to present. Yeah, so as John mentioned, my main work that I do right now is CERES Education Outreach is focused around hazard resilience in rural Colorado. So as someone was saying about collaboratives on Zoom, it's actually been a big benefit for me because being out here in Gunnison, I feel like I actually get to connect more with people. I feel like I have more people in this remote world with me. And I think it has been, in a way, there's been some benefits for more inclusion of rural teachers. Someone mentioned the Colorado Science Conference. It's one of my favorite events of the year to get to see people from all my past jobs and connect. But I think this last year, even though I didn't love it online, it was a really great opportunity to have a lot of people participate that often can't make the drive to Denver. So anyway, so today I'm presenting this data puzzles project, and I get to work with a fantastic team on this. I think Bella mentioned data nuggets, which is something that we've always admired and liked. And this is kind of our iteration of data nuggets. So we reached out to the data nuggets team and never quite found synchronicity there. So we kind of started these, and John Griffith, pictured next to me in the bottom left, has been kind of the main push behind this. And then Lynn Harden as well has been a big part of the effort. And I feel like I'm just kind of been a joiner, but feel really honored to get to work with the team. While my kind of home base and comfort zone is usually kind of more project-based learning, and the work I do now is a lot around building community resilience and taking action. This is more of a hard science piece and really working on data literacy and working towards aligning with NGSS. So, but it's a really fun project that's just in the beginning. So it's fun to be able to present this to you all today, and I welcome questions, ideas as we continue to develop these projects and the data puzzles. We're looking for as much feedback and as we develop and get further along in the project. So, and then of course, the director of our office, Dr. Anna Gold, has been instrumental in the development of these data puzzles as well. And then what makes data puzzles unique, I'd say, and a little bit different from data nuggets, is this fantastic partnership that we've started with Melissa Bratton. She's a professor in the School of Education at CU, and she's a co-author of Ambitious Science Teaching, and I'll be talking a lot about that resource, but it's been absolutely wonderful working with her. She's a veteran classroom teacher, and then just has this amazing wealth of knowledge, research knowledge about how students learn best in the science classroom and supporting science teachers in the classroom. And then also Carrie Wingert, curriculum designer for Inquiry Hub at CU Boulder, and she's been a great partner on this project as well. So we have a great little team of folks working on these data puzzles, and I'm excited to share today. And please, if you have any questions, throw them in the chat or just interrupt me and speak up, and I'd be happy to answer. I'll probably chat for 20 minutes or so and then leave time for questions at the end. So the inspiration for data puzzles, the first ones were with the MOSAIC expedition. If you haven't heard of it, it's a pretty amazing expedition, international expedition, where they intentionally froze a ship in the ice that drifted across the Arctic. From September 2019 to October 2020, with more than 500 scientists from 19 countries, studying everything you can think of about the Arctic climate system, ocean, ice, atmosphere, and ecosystem processes. So just as these scientists created this huge amount of data, John and Lynn were running the education and outreach efforts for the project on the US side. And that's where they conceived the idea of data nuggets, to kind of in the same process as the scientists come home and are trying to process and analyze this data. That's also what the education and outreach efforts team is doing for MOSAIC data as well. And that's where data puzzles came from. If you haven't seen the resources, the MOSAIC educational resources are pretty amazing. I don't know that the URL is up here, but I'm happy to throw that in the chat later. But that's where kind of data puzzles were originally. And one of the really cool things that we were able to do on the MOSAIC expedition was collect VR, virtual reality footage, which is using a 360-degree camera. So one of the goals of data puzzles is to connect students to the data collection and get to visualize how data is collected. Thanks for throwing that in there. And so these VR projects, you can kind of explore, move around. I won't give you all motion sickness. And then click on different things to get pictures and a little bit more information. So they're a really cool resource that students get to go out onto the ice in virtual reality. You can use it here, but then there's also these really cheap Google glasses, which are cardboard. I'm sure you all have seen them, kind of cardboard glasses that you throw a smartphone into and actually get to look around as if you're out on the ice. So that's a really cool thing. A lot of these the existing data puzzles for MOSAIC are connected to these VR expeditions, and so students get to see where the data is collected. And that's a goal as well for as we create more data puzzles. We are planning to create as many resources or provide resources to connect students to the data collection itself and where the data is collected. So data puzzles are a combination of data sets, authentic data sets from scientists, and then incorporating 4 practices from ambitious science teaching to help students make sense of the data and analyze the data. We intentionally have written the lessons to be no more than 3 days long, so 2 or 3 days, with all of the amazing curriculum that's coming out with OpenSciEd and other resources. Those units are amazing, but they can take 2 months for a teacher to teach. So these are intentionally short for teachers to integrate into their curriculum using authentic data. So ambitious science teaching is research-backed pedagogical framework with 4 core practices for inquiry-based learning. And so I'll kind of talk about each of these practices and how it's incorporated into data puzzles, but I'm going to really quick just share the ambitious science teaching website is fantastic. There's a book, but then there's also the website, and I love going into the video gallery. But it's all free and accessible, but there's lots of tools to share with teachers for these practices, and it's been adopted. I think Melissa said it was in 40 states or more, but it seems like it's been really popular framework for teachers and used across the country. So the first practice, and when I'm chatting about what I'm going to do is just kind of walk through one of the data puzzles as an example and the practices, and I'll go back. Also another idea and kind of premise of this is that we're working on now creating data puzzles and creating them in a format that anyone can make their own data puzzle. And so that's something that we're working out. We hosted, as I think one of the attendees today mentioned, we had a workshop this summer with several teachers who are co-creating their own data puzzle. So we're trying to figure out, they're really challenging, we found, to write, and how do we make them less challenging and create a format that anyone that has a good data set can create their own data puzzle. So I'd say that's kind of our one of our ultimate goals with data puzzle is making it open source so anybody can kind of take these tools and run with it. So, and I will walk through some of the MOSAIC data puzzles to share with you today as examples. So the first piece is eliciting students' ideas. And the purpose is to find out what students already know about science ideas included in the data puzzle. And I'd say that this is one of the places in the data puzzle where we really have a lot of focus and attention on equity. And so creating opening scenarios that students engage with and are able to connect personally to. Especially with MOSAIC, you're thinking about somewhere on the poles and that students have never been to or most likely will never go to, but are there things that connect to them and their daily lives that we can start to elicit their ideas and start to know what initial ideas students have about the concept. So example here, a scenario is snow blindness. And while I just said that there's a big focus on equity, one of the concerns about this one is not all students live in a place where there's snow. So we've talked about having a menu of opening scenarios so teachers can choose something that will directly relate to their students' experience. So in this example, it's about Johnny who went for a walk across the snowy field without his sunglasses. And he came home and his eyes began to feel watery and irritated because of the reflection off of the snow. So this opens the lesson, and the idea is to get students thinking about what do they notice and observe, what ideas do they have currently about what's happening here, the phenomena that's occurring. Then we introduce and start to collect those ideas and have a record of what students are currently thinking about the concept. And then introducing the scientists. The data puzzles all focus on one or more scientists and bringing some personality to them and making them real people. Jen Kay from CU is the scientist featured in this data puzzle, and kind of a short introduction to who she is. And she's interested in the amount of sunlight reflecting from the Arctic and how that might be in response to melting sea ice. So after we've started to elicit students' ideas at the beginning, Then using a reading to connect science ideas to the students' opening ideas from the opening scenario. So the purpose of that second piece is to connect students' ideas as they relate to the opening scenario to a new scenario, which is where the future scientist is actually engaged. And so we use close reading strategies embedded in the curriculum in the student worksheet. Students also use the reading to identify a science question, and then also make a prediction using evidence from the reading for the scientific question. If anyone is familiar with argument-driven inquiry, that's very similar. Short reading that is kind of jam-packed full of the core science concepts that are important for the student to know and understand to complete the data puzzle. So in this case, we're talking about a data puzzle to reflect or not to reflect. It's about albedo. These are some of the core science ideas. You'll see that they're written in accessible language. And these are kind of the core understandings that students need to have to solve the data puzzles. So talking about when energy is absorbed, most temperatures increase. Lighter colored surfaces reflect more of the sun's energy than dark colored surfaces. Arctic sea ice is declining, thereby exposing more of the darker ocean at the surface. Great question, Tracy. They are not in Spanish, but we would love it if we could have the funds to translate them. But we don't, currently they're all in English. After the reading, students make a prediction. So they're asked to pull the scientific question out of the reading. In this case, it's how might the Arctic's albedo be affected by the observed decline in sea ice? And then really providing a lot of scaffolding for students to make their prediction. So students would circle that Arctic's albedo would increase, decrease, or stay the same as the extent of Arctic sea ice declines because ... Students fill in their prediction. So once they've done their prediction, next it's supporting ongoing changes in thinking. So in ambitious science teaching, the purpose here is for students to confirm or refute their predictions. And by analyzing and interpreting authentic data, establishing rules if present to describe relationships between factors represented in the data in the graph, and then reflect on the patterns and relationships to evaluate initial predictions for the scientific question. It was really fantastic working with Melissa on this piece because she had a lot of great insights from her research on how to do this effectively. So in this case, here's the data set that we use, albedo over time and the average sea ice extent. And I don't have it in the slides here, but Melissa found that with students, if instead of asking them just a general question, what's the pattern you see in the data, you can use strategies like what is the albedo of sea ice in 2001? And then what's the albedo of sea ice in 2012? And actually give them specific points within the graph. And then that kind of gives students scaffolding to look at the different data points within the graph and then make conclusions based on the observations that they've made. So that's included on the student worksheets in the data puzzles, are these strategies that will help students really pull apart the graph. This is kind of a more complicated one, right, with two y-axes, but we really do think intentionally about the level that the data puzzle is for, and then also thinking about simplifying it for students. Another thing I'll note is that on our wish list of things to do is adding some differentiation here, just like Data Nuggets, I think, has this. You know, for some students, giving them a data table and asking them to graph it. For other students, giving them the graph. So having some options for differentiation for teachers. Then the last piece is students create an explanatory model to communicate their new understandings and science ideas as they relate to the scientific question. So the first piece is construction of a gotta have checklist. This is straight from ambitious science teaching, and they have a great little video on the website about what a gotta have checklist is. But that is really a classroom discussion on what is important to include in the model, what concepts are important to include. Also, how do we represent different concepts on our model? And I'll show a slide in a minute of different tools that students could use in their model. And then students create their conceptual model using the gotta have checklist, and you can do a gallery walk where students check out each other's model and have some discussion around models, and then finishing the lesson up with future research questions. Here's some modeling conventions. So this could be part of the gotta have checklist, giving students some conventions and different pieces that they could incorporate into their model. Obviously, as students do more models, they'll get more successful and be better at putting these together. But spending some time talking about how would we represent incoming energy versus outcoming energy, for example, and all using the same convention, so everybody is on the same page as they develop their models. So here's an example. We create these little images for students to draw their models. That's also out of Melissa's research, that if students are given just a little bit of help, just some simple images to start with for their models, they are a lot more successful than given a blank page. So this is something, our image straight from the student worksheet. And then this is kind of an example. One thing that we talk about with teachers and have had lengthy discussions with Melissa about is how to grade and assess these. And Melissa really emphasizes that it's so easy, and having been a classroom teacher myself, it would be the first thing that I would do is take my gotta have checklist and use that as a rubric to grade these models. And Melissa says, no, that is absolutely not the way to do it. I'd say a better suggestion might be to look at the development of students thinking from their first model of initial ideas and to their last model. We haven't gotten a great answer from her or from teachers on the best way to grade these conceptual models. But I think having an eye for the level that students understand the concepts, rather than, did they include this, this, and this? Did they include a thermometer? Did they include a representation of sun's energy? But I think it definitely takes a little bit more time for assessment than just going down a checklist to see what they've included in the model. The last piece is having students think about new questions. What questions should be investigated to better understand the concept? As I was getting familiar with data puzzles and the ones that, the MOSAIC data puzzles, thinking about writing my own, it's such a challenge on what data to include and how much information to include. Obviously, students are not going to have access to all of the data that they need to answer the driving question. Often the driving question could be a master's thesis or a PhD dissertation. But this is kind of our opportunity for students to ask more questions about what would they want to explore further on the science research. As I mentioned, we've had 2 workshops this summer. One that was kind of a big introduction to teachers to data puzzles and the pedagogy behind them. And then just 2 weeks ago, we had our first co-design workshop. We had 7 teams of teachers, of 2 to 3 teachers, and I should say educators, because some are classroom teachers and then some are informal educators or curriculum developers. So we had a really diverse group of teachers, and that they're working with scientists. We've kind of, in order for efficiency, we've curated the data sets first and came up with the scientific question, and then gave that to the teachers in interest of time. Ultimately, we really would like to be truthful and adhere to the true concept of co-design. In this case, I'd say it's definitely more guided on our part, given our short time frame and just kind of experimenting to see how it goes. So right now, there's just 3 data puzzles published on the data puzzle website. But here's some examples of ones that we've got in the works with these teachers. There's an onshore versus offshore wind energy production, with Julie Lundquist, who's at Atmospheric Sciences at CU. One is the influence of latitude on the survival of moss species, with Dan Doak, who's at CU, and then Megan Peterson and Bill Morris. I forget where Megan is. Bill's at Duke University. And then changing water supply and use in the upper Colorado River Basin with Seth Aarons. So this has been a really fun process, and we're learning a ton. Just as John Lynn and I are writing these data puzzles, we're learning so much more as we are asking teachers to write these data puzzles. And we're kind of fine tuning and figuring out how these work. And that also, I didn't mention, we have had teachers pilot these data puzzles and give evaluation on them to us last spring, but by no means are these, is the format final. It's still in development. And yes, great question, Beck. They are all available. And the website, which I'm surprised I didn't include in the slides, is datapuzzles.org. So they're freely available. And we'll be adding more and more as we get more and more. But I'd say as a group, I think as an education outreach and especially the curriculum development group, we all gravitated toward this because it is really transferable, the format, and we work with scientists across the board. And so we were all excited because this can be an easy kind of way to develop curriculum with scientists in series because we work with all sorts of folks. And then also, like I said earlier, creating it a format or creating tools that people can easily create their own data puzzles. So yeah, here's my email. Feel free to reach out if you have questions, or also we are on Twitter. John mans our Twitter account, and anything about data puzzles you want to learn or any upcoming opportunities, they will definitely be on Twitter. And you can learn more there and also at the websites. Yes, I see Richard's comment, using different graph types, scatter plots versus time series. We've also talked about, can we use spatial data? So especially with the Natural Hazards Project, I work on a lot of that data, looking at wildfires, frequency, impact, burn, risk. A lot of that is spatially related. So really kind of pushing the boundaries of these data puzzles and see all the different types of data that we can incorporate, not just a plot or a graph, but thinking about how we can stretch the format for different applications. So I think that's all I've got. I'd love to hear any questions or feedback, but thank you all for letting me share today.
Gotcha. Questions? Yes, let's hear. Thank you, Beck. Yes, let's give a round of applause. Thank you.
Round of applause. I like that.
Any questions for Katya? Mike?
Right. Katya, how many days the data puzzle you shared? Do you know how many days that was intended to be in classrooms?
About 3, I think, and I can look directly on the lesson plan. I think we tried to keep them beneath 150 minutes of instruction time.
Because I agree with the open science stuff is great, but it's months, not days, right? Mm-hmm. I think there's also, with data puzzles, I think the benefit to it is that you apply these skills around this piece of content, but it doesn't have to be a one and done because it only took 3 days, right? You could continue to look at factors that are influencing climate because you've invested 3 days, you maybe shift around the topic and come back. I think that's pretty awesome.
Thanks. Yeah, one thing that we've talked about with teachers, thanks Tracy, it says 180 minutes. So another thing that we talked about, that these can be used at the beginning of a unit. It can be used as an assessment for a unit. So thinking about where teachers put them in their units and different data puzzles. I'm working currently on a series of data puzzles on wind. And there's some that lend themselves, wind is such a complex phenomena. And so there are some that really do lend themselves as a summative assessment where students need to pull together all the different pieces. But also data puzzles are not meant, you know, there's the narrative in the middle of the data puzzles. Students ideally are already familiar with the concepts before they do the data puzzle. So we don't expect that teachers would use, for example, this data puzzle to just talk about, I think albedo might be more of a teachable concept within in a day or two, but you know, if students aren't familiar with the energy budget, we don't expect that students are going to understand the energy budget just with this data puzzle. They're meant to be more of an accompaniment and a way for students to engage with authentic data to deepen their understanding of the concept. It's not meant to teach the concept in 2 days. So,
yeah, just a comment. Gary Harris. Here in Hampton Roads, Virginia, what we're trying to create the country's largest offshore wind hub.
Cool.
So we see between North Carolina and Virginia, we're putting in gigawatts of capacity offshore. Just took students offshore 27 miles. We have two 12 megawatt pilot turbines out there. We're going to install 188. Which will take us up to 5.2 gigawatts. On the East Coast alone, we're installing 30 gigawatts and such through about 12 leases along the East Coast shore there. So offshore wind is a big deal here in Hampton Roads. Again, we're trying to vie to be the supply hub for the entire East Coast. About $100 billion worth of manufacturing, employment, workforce, etc. I say that because we're scrambling to find outreach materials. You know, yeah, we're scrambling to do that. I'm on the workforce committee here and such. Also through the Sierra Club, we're trying to do community outreach as well. So I wake up in time for this data puzzle presentation. So thanks a lot. I'll be contacting
Gary, we'll try to share the onshore one with you. I think, are you in competition with the offshore project off Martha's Vineyard? Because that's what we're using. Martha's Vineyard site.
Where? I'm sorry.
Martha's Vineyard up in Massachusetts.
Oh yeah. Well, it's all a collaboration.
Gotcha. Yeah. Well, yeah, we'll be happy to share that with you as we get it developed. And the question is, why are offshore turbines more productive than onshore? And, and talking about the concepts of friction and everything there. So.
Okay. All right. Great. Super.
Well, very exciting news about, all the offshore wind production.
Yeah.
Oh, this is Rich. Yeah, thanks to Gary for sharing that. I think that would be really interesting for, I teach a lot of courses in sustainability and that kind of thing. So those kinds of technological advances and trends are really exciting. I'm a neophyte when it comes to VR, but I can see some really great ways to kind of finish up this, but it's predicated on the fact that you have your students have already done some things with teams where they're out there collecting the data themselves, and they understand the idea of setting up teams and having different roles and the importance of timing and accurate note-taking and all of those things, so that when they can envision what has to be done next, they've seen the VR, they've seen what's available, then they can almost visualize themselves going out there and, okay, our team is going to go do this and we're going to do that. And so it seems like a really nice way to extend beyond what they've already done, if they've already have that hands-on stuff, so to speak.
How cool is that? I mean, really, getting students to think as the scientists, and as many resources as we can provide for students to get that experience and see the scientists as humans doing cool work. Yeah, I love that. And yeah, I would also say with the having students collect their own data, if there's a connection to GLOBE protocols or other data collection students are doing, like I said, with the opening scenario, that can look, we want that to be flexible and kind of have a menu, but that could be an opening scenario, taking some data that students have collected already, or going out and collecting data in a different way, and then giving students a common experience that they can all relate to, and then build upon that experience to connect to the data and the data puzzle.
Other questions, comments?
I think that this just has some incredible potential. So, I mean, they're targeted at middle school, high school, and I'm just picking up on a comment that Rich put in the chat about changing the type of data visualization you ask them to do, right? Just is a really cool thing to be able to do, but I think you could also even change levels, because the topics like energy budget, right, is a topic that is from grade 3 all the way through grade 12. And so the ability to be able to take smaller pieces of data and make sense of that, and then continue to add to the quantity and the complexity of data. So in a sense, you're making a data puzzle, and then you're just developmentally ramping it up by grade levels. I think that's pretty cool.
Yeah, I love that. Yeah, we've had to adopt just the mindset of, I mean, when really digging into these and writing them, it's, I think, really challenging to really just focus in on the fundamentals for each one, and really streamline the data puzzle as much as we can. And I've had some great conversations with Julie, the scientist, atmospheric scientist that studies wind. And of course, she's so passionate about the science. And so we get tons and tons of ideas. And so we've had to adopt the phrase of, okay, that'll be our next data puzzle, or put that in the addendum, because we keep having to come back. And I'm really curious to see how the data puzzles turn out written by the teachers, because they fully understand the importance of paring down the science to the fundamentals. And yeah, scientists, are often, we get so excited and get so many ideas. And so I think there's endless data puzzles to write. And I love the idea of kind of through the levels, creating them and adding to the complexity, which I'm working on one right now for 6th graders. And I'm trying to, and as when I taught 8th grade, I was amazed. Many of my students still couldn't make a graph. So while I say writing a lesson for 6th graders, I think making it accessible to what I think as a 3rd or 4th grade level, and making it as accessible as we can for students. So,
well, don't feel badly. Some of my seniors here in the university can't make a graph either.
Yeah.
Okay.
Which is why we need these, which is why we need data literacy.
Michael, I was just thinking that some of us as higher ed people could do with learning from some of these great literacy and education initiatives from our colleagues in the middle and high school arena.
Yeah, it was funny. We did a data literacy study this past spring for future teachers, and it was interesting because some of their housemates or whatever were in the sciences and were absolutely blown away by what they were. I mean, they had no idea what they were doing and why it made a difference how you represented the data. It was really funny. So a value added to the work, I guess.
So thank you so much for sharing all of this with us. Of course, I'm like, my mind is going a gazillion miles a minute now. But I want to be honest with you. So the term data puzzle, right? And I'm going to teachers and I'm telling them about this wonderful resource. And if a teacher would present it to a student as a data puzzle, my mind goes one place, the reality is someplace else, right? So either I'm not getting the puzzle piece, it's more of a matrix, you know, and this kind of, I see this, you know, I'm reading the ambitious science teaching, you know, terms that are in the circle. And I'm wondering if we're really using data to teach a concept, or if we're using, or if the focus is to apply what they've learned and data is a secondary. I mean, like data opens it up. I'm not saying this right because I'm just thinking about it right now, and I probably should think a little bit more before I talk. But is this making any sense? Have you gotten any feedback from your teachers from this kind of puzzle perspective? And how do we, because I can really see these four corners of the circle really fitting in as to, because I know this, oh, this goes here because it matches, right? It's like this progression of learning instead of these separate, you know, pieces kind of stuff. And I love the apply piece as that. Now that we've learned this, what kind of questions, you know, what else do we need to know, that hope, the checklist part, right? So I don't know. I'm just throwing that out there.
That's great. So I guess what I hear, so one is a question of using the word puzzle, and the meaning of that. And then one was, is it meant to introduce a concept, or is it meant to drive the concept home?
Right.
I'd say either or both. Teachers are going to use it all different ways. And that's something that, yeah, I think about, like I was talking about earlier, using them as a summative assessment to apply what's the conceptual understanding that students have to a real world data set. But then on the flip side, I could see a teacher using it to start to get students thinking about the concepts and then really use it as an opportunity to dig into the concepts. So that, I think, is somewhere that we need to do more thinking about. Do we want to label them or direct teachers to use them as an introductory activity or a summative, or how they want to use it? My personal philosophy as a fledgling curriculum developer is that I'll put together what I can, and then the teachers are going to do with it what they want to do.
Absolutely.
So
absolutely,
like, I kind of think, even if I tell them that it's supposed to be an intro activity, a teacher will still take that and say, oh, this would be perfect here, you know? And then with the other piece on puzzle, I really love to hear your thought process on that. From a really kind of frank perspective, nuggets was taken, so the next best thing was puzzles.
Yay. No, it's all good. It's all good. And I'm not criticizing or anything, but I had in my head, because I didn't, you know, I didn't have any pre-work on this, so to speak, right?
Sure.
You know, and I actually see this, if we look at NGSS, which is, you know, I'm in California and, you know, all that NGSS, I mean, the whole modeling aspect of this, I think, is what really brings it home in terms of that connection. And I mean, not too many students and teachers are going to be all that excited about the Arctic ice in terms of it's not in my curriculum, kind of, you know. You know, so making the connection that this is about ecosystem health, and, you know, making that connection by using the Arctic as an example, but not maybe as a student might be as excited about that than, you know, their own, you know, rural community or urban community, and using it from that standpoint. But anyway, I was just talking out loud.
The ones that exist are really just a you know, as a lot of things are, they're a product of the funding that we had and projects we had to do. But our direction is we do want to make ones that are way more universally accessible, and that can be accessible to students with lots of different experiences. And as I'm sure you all have encountered in your work, the questions that scientists ask are not the questions that students ask. And so we kind of are getting creative. Like I'm working on one today about air pressure and how air pressure changes. That's the 6th grade one I mentioned, how air pressure changes with elevation. Very well understood concept for scientists. There's no questions there, but there's a scientist that we're working with that is testing out unmanned aircraft, drones to measure air pressure and other atmospheric parameters. So we're using him as our focus scientist, as somebody that's testing out new technology to measure a concept. So it's kind of a stretch. So figuring out how do we still stay authentic to the science, but often I think, and John will tell you this himself, one of his least favorite data puzzles is about a crack in the ice. I think it's the 3rd one up on the website, which is so obscure. And he's like, nobody's going to use this, you know? So it's one of those of like, as we build out our collection, we really do want to steer towards ones that are going to be more universal and used and can connect to students across the country in different scenarios. So yeah, it's a great point for, it's challenging to connect. But it was interesting hearing your discussion of the different pieces for ambitious science teaching, and then those as a puzzle, because I hadn't even applied that or thought about it that way. But yeah, if anybody has any other ideas, and I will say there is a book published of data puzzles from NSTA in like the early 2000s that another teacher shared with us, which is a totally different format. And we need to reach out to them to see if I don't think they have any more planned, but we did do a pretty thorough search of trademarks, and still there are things that missed the search. So yeah.
Well, thanks for indulging me there. I appreciate it.
Of course, yeah. All feedback is appreciated. And thank you all for your questions. And we'd love to keep engaging. Like I said, follow us on Twitter, check out the website, and stay in touch.
Thank you, Katya. Let's give another round of applause for Katya. And thank you all for the engaging questions and comments. I think that's all really helpful as we learn from each other. So we will send out a quick 3-question survey to everyone who came. So I encourage you to take a moment and let us know how you thought this went. And then if you would like to share a webinar like this in the future, just contact Deanna or me, and we'd love to have others of you share things that are going on in your area with others, other collaborative teams. And I think that's all I have. Deanna, I will give you the last word. Do you have anything you want to say?
Actually, I had a comment or a question. I don't know which it is, but I wonder if you're cataloging these in any way to relate to some of those larger concepts, like the Earth's energy budget may have other pieces that could have other puzzles, but would be connected to that idea. And I wondered if it would be helpful to teachers, because somebody mentioned Earth's energy budget is something that's taught from 3rd through graduate school.
Yeah.
So
the cataloging question, we don't have enough to catalog yet, because we have 3, but we'll have a lot more. But also to talk about the bigger concepts, I am working on, I mentioned these wind data puzzles, and so far we have 4 in development, and I'm planning on writing a storyline that connects all 4. So they'll plug in, and so having some of the classic hands-on experiences like the, can crush activity to talk about pressure, but then using the data puzzle is do this hands-on and then use this data puzzle, but having kind of a storyline as an overarching framework for data puzzles to string them together. But that's the first kind of, really seeing if we can build a unit out of data puzzles and see how that works. But yeah, I love the idea of kind of cataloging them under these big.
And I love your idea of connecting the concepts in those ways, because it's because I think sometimes the connectiveness gets lost in the specificity of a certain idea or concept, but kids, once kids see the connectors and teachers, they can't unsee it. So.
Right. Yeah. I mean, even you could do a big explanatory model that has all of these little ones, just build on it for a whole quarter or semester or unit. I mean, with the little pieces of the explanatory model could be really cool.
They're really cool. Thank you.
Yeah. Thanks, Deanna.
Alrighty, well, we don't have a next water cooler coming up, but if you have an idea, let us know. Otherwise, we'll keep you informed. Deanna's been the master of getting the newsletter out, and so thank you, Deanna, for that, to keep everyone connected, and feel free to email us if you have questions or comments. Thank you.
Thank you, John.
Thanks, y'all.